Uh, Now I'd like to go over the theory from Piaget. I also want to say that the video I posted from Films on Demand, it starts off with Piaget speaking in French. And that goes on for a little while with subtitles, but don't worry. Uh, It they just wanted to give you an example of an actual uh, video of Piaget. So, and then it moves to English and a few other people who worked and studied with Piaget, and it goes over the theory with video examples. Um, so this is a little longer theory. So bear with me, please. But I also want to say that all of the human growth and development theories, um, especially Erikson, Piaget, a few others, really do appear quite a bit on the comps and the NCE. Um, so really try to get this information down. Um, in a way that you can retain it so that you'll do well on those. So one of the things that I found really interesting with all the theorists, but Piaget is one of my favorites as far as his personal history. Um, and I want to go into some detail with that, just because I just think it's fascinating. So his theory is the most widely discussed theory of adolescent and cognitive development, um, and also I would say uh, not only adolescent, but I would say all ages of childhood development. Um, Now, I do need to caution you that there's been a lot of debate that people try to uh, discredit his theory because the ages don't really match up with what's happening. So take that with a grain of salt. Uh, I think the stages do occur, but they might not occur at the exact age that he specifies. Um, so the ages in reality might differ, but I think what actually happens uh, it does match his theory. And I know that my wife gets pretty sick of me pointing out, since we have 4 kids with every child, all of the different stages of Piaget's development as they are happening. So everything from object permanence, which she calls peekaboo, uh, to uh, to other things. So a little bit about his personal history. He was born in Neuchâtel, Switzerland. He's the oldest child, uh, and of Piaget. His father, author, was a professor of medieval literature at the university and began to teach Piaget to think systematically. His mother, so systematically is important here. Uh, his mother, Rebecca Jackson, also very bright. However, his father seemed to be somewhat detached from his mother and was prone to frequent neurotic outbursts, um, as described later by Piaget. At the age of 11, while he was a pupil at Neuchâtel Latin High School, he wrote a short notice on an albino sparrow. And this short paper is generally considered as the start of a brilliant scientific career made of over 60 books and several hundred articles. Um, so that's pretty young, 11. Um, in later adolescence, he volunteered to work with the director of the Museum of Natural History and, uh, and conducted experiments on mollusks. The director died unexpectedly. Piaget wrote his own description of the experiments, had them published. As a result, he was offered a job as curator of the Geneva Museum. That's a pretty big museum, which he had to decline due to his age. I'm not sure his exact age, but adolescence. Piaget completed his PhD at 22 from the University of Neuchâtel in natural science. So up until this point, everything was in natural science. After a semester spent at the University of Zurich, where he developed an interest for psychoanalysis, he left Switzerland for France. He spent 1 year working at the École de la Rue de la Grange au Bel. I think I got that right. Boys Institution created by Alfred Binet. So and then directed by the people say Simon, who had developed a test with Binet for the measurement of intelligence. So of course, Alfred Binet developed our IQ test. There he worked with French school children and standardized Binet's tests of intelligence. It says Bert's, I think that's a spell correction. That is an error. At first, Piaget became bored, but then he became interested, and this is really fascinating, interested in the children's wrong answers. And you say, well, why? Why would he focus on the wrong answers? Well, remember that early on, his father had really trained him in systematology, systematic thinking. And what he noticed was that all of the incorrect answers seemed to follow some type of theme or schema or some type of similar reasoning that was shared by children of the same age. So that's the beginning of his thinking about learning and cognitive development. So the incorrect answers following this theme by children of the same age, or perhaps the same developmental stage. He later explored this concept of developmental reasoning and growth. In 1921, and here's the interesting thing, just with my own 4 kids, they all achieved various stages at different ages, slightly different, but they did achieve the same stages. Now, some of my kids excelled at certain stages, other kids excelled at other stages. Some of them had to work on certain stages, others at different stages. So it's different for every child, I think. So 1921, he became the director of studies at the Rousseau Institute for Child Study and teacher training, and that's misspelled as well. In Geneva, at the request of Sir Ed Chapered and P. Beauvais. Just want to make sure I try to pronounce these as close to the way they should be pronounced. He was still only 24 years old, so he was quite a prodigy. 1923, he and Valentine Châtenay were married. The couple had 3 children, Jacqueline, Lucienne, and Laurent, whose intellectual development from infancy to language was studied by Piaget. So we can guess that a lot of his developmental stages were based on his own children. I'm not sure, but that might also be a reason for the ages not to be quite as generalized or exact. Funny that most of the ages seem to be a little behind when compared to today's children. But all right, so let's look at his theory specifically. So more information does not equal more advanced thought processes. Piaget believed that it is the differences in understanding the world and its information that makes one stage more advanced than another, not specifically the information. Piaget believed that children's psychological structures changed with age as they grew and developed. This reflects why children of the same age had similar wrong answers. Adolescents adapt their thinking to include new paradigms or ideas. Piaget maintains that adolescents are motivated to understand their world because doing so is biologically adaptive. Well, yeah, so, you know, they want, they're in this transition period. They want to better understand the world around them. They want to do that socially, but also in their work and school, in all areas of their life. So this is much more than Locke's tabula rasa. So I described this in my theory class. The tabula rasa, the raised or erased tablet. Remember, the early students would use a handheld chalkboard, so, or slate tablet. And they would use chalk and then they would erase it when they were done. Well, Locke thought our minds were like that we were born with a blank slate, tabula rasa, and everything we experienced, we then learned. So he believed in nurture versus nature. We know today it's not so simple, it's both. Adolescents actively construct their own cognitive worlds, sifting through ideas based on importance or value and connecting ideas based on schemas. So remember all the schematic things. So here, schemas is a big part of his theory. Schemas, specific mental concepts or frameworks, are called schemas. These are used to organize and interpret information. At a very early age, they are based on motor actions like the dropping of something. My kids always make it a game at a certain age to drop something off the table because we pick it back up. After the 10th or 20th time, we might leave it on the floor and they cry. Schemas move from action-based to mental level or thinking before acting, dropping a ball on purpose, or spoon or plate or bottle. Schemas become more complex as children become adolescents. Now, so as we enter adolescence, we really think about the predictability of a schema. Children and adolescents incorporate two processes to adapt to their environment and create changes in schemas: assimilation and accommodation. You should remember this. So adaptation, children adapt through repetition on interactions with the environment. Assimilation, when children incorporate new information into current schemas to interpret the world. So um, we might think about, uh, okay, children might see a dog for the first time. They categorize that dog. Accommodation, however, is when current schemas don't fit the environment, then they have to be adjusted or new schemas are created. They see a cat for the first time. Well, that's not a dog. So they create a new schema, cat. It sounds simple, but when we're thinking about all of the environmental learning that is going on, it's really an incredible amount. Equilibrium refers to the shifting of one thought to another thought. When someone experiences a cognitive conflict or disequilibrium, um, other theorists use other kinds of words for this, like incongruency. Um, in trying to understand the world, a shift in thought occurs. Eventually, the situation is understood, and as the conflict is resolved, a state of equilibrium is once again experienced. And of course, people might experience some anxiety when there is disequilibrium. Organization takes place internally to arrange and link schemas into a cognitive framework. And if we're actually talking about this on the cellular level, where neurons grow new dendrites, and those dendrites actually create a physical and chemical connection or a new cognitive map within our brain structure. But this is a concept, not the cognitive map. It is a cognitive framework. Equilibrium is achieved when schemas are adapted and become part of a larger network. Um, so remember when we talked about Konrad Lorenz and um, there were windows of opportunity. So for instance, music. Somebody began learning about music or how to play an instrument or how to read music or language at a very young age, or foreign language, two languages. Um, that would create more dendrites, more connections for neurons to make those electrochemical connections in our brains, actually forming that cognitive map. Um, so as we move through these theories, you'll see that even though these are individual theories, they connect in many ways. So let's look at his stages of development. So age 0 to 2, sensory motor stage, 2 to 7, pre-operational stage, 7 to 11 or 12, concrete operations, and 12 and forward, formal operational stage. An individual's cognition is qualitatively different from one stage to another due to age and developmental growth. We're going to look at each one of these stages in more detail, and we also have a lot of sub-stages that need to be considered for this. It's a lot to memorize, I know. So Piaget, he observed many children, including his own, to develop these stages. However, as I said, recent studies show that children are more advanced than Piaget thought. They also do not change and grow in such structured steps, yet many of his observations do occur and are quite valid in early testing. Um, so I started kindergarten early at 4. I was in preschool at 3. Um, but I had to pass an IQ test in order to get into kindergarten. I remember it pretty vividly. One of the parts of the test was an observation and memory test, and I remember going into the psychologist's office, and after talking with me and after taking uh, IQ tests. Um, we did this test, and one of the things that he said was, okay, whatever I do, you need to remember it. And then when I ask you, you need to mimic it. You need to do the same thing that I did. So he goes over throughout the room and does various things. And he says, sits down, and then he says, okay, you do the same thing. And it wasn't that difficult, but I opened a book, I moved a pencil, um, then I coughed, I pulled up my pants, and I did a number of other things. And of course, his response was, did I really do all that? I'm like, yeah. So he had a laugh at that. Um, so it is so interesting um, working with all children. All children, I think, have gifts, and all children have struggles. But one time I worked with a child that had an off the chart IQ. It was a girl in third grade, and it wasn't the information that she knew uh, that fascinated me. It was what she did with the information that she had. It was the connections that she was able to make. Um, and of course, I love talking with her. Um, so, sensory motor. Um, let's look at the first stage a little more in depth. An infant constructs an understanding of the world by coordinating sensory experiences with physical actions. Circular reaction. A union is first. An action is first caused by motor activity, then the infant tries to repeat the activity. If successful, it becomes a schema. It's usually fun for the child. It's a discovery. It turns into a game. So there are 6 substages. The first month, reflexive schemas, sucking and grasping indiscriminately. So taking a bottle, these are all instinctual. But 1 to 4 months, primary circular reactions, first learned adaptations. The child begins to gain control over the actions through circular reactions. Simple motor habits begin as well as varied reactions to the environment. Hey, if I cry, my parent will come and hold me. 4 to 8 months. Secondary circular reactions. The child has a desire to make interesting sights last longer. He or she uses reaching, grasping, manipulating. They often play with, those mats that lay on the floor, and they have like things, little toys hanging down, and mirrors, and noisemakers, and little animals. And so he or she uses reaching, grasping, manipulating, more advanced secondary circular reactions. If I push this button, it'll make a sound. If I push this car key button, it will make a sound. 8 to 12 months. Coordination of secondary circular reactions, schema organization and more complex action sequences with intentional goals and directed behavior begin. So here we're talking like object permanence. At this age, children should be able to find the hidden object. So we play peekaboo with the baby blanket. No, when I raise the blanket, I didn't actually disappear. I'm behind the blanket. And they reach out, pull the blanket down. It's a great game. The object is interesting enough to find. Now here's the thing. Try this with your dog if you have one. Hold up a blanket, let them sit on the couch or on the floor. Hold up the blanket, and then as you drop the blanket, run around the edge of a door so they can't see you. Run into a different room. And when the blanket falls, they will not know where you went, and they'll have to find you. But it is kind of funny. Prediction. A child can anticipate events, also action, reaction. Imitation begins. They begin to imitate quite a bit. 12 to 18 months, tertiary circular reactions. Children discover new means through active experimentation and begin to explore the world around them. They become mobile. They are crawling everywhere. 18 months to 2 years, mental representation, the terrible twos. Children invent new means through mental combinations. And they're able to store, recall, use images of absent objects and past events. So they're using their memory recall to a much greater extent. They can then practice deferred imitation through memory. Children practice a great deal of play and make-believe. And they have adventures at the terrible twos. They often fall off the couch because they don't understand the consequence yet. They can't predict the negative consequence. All they know is it's fun to jump on the couch. Okay, the next stage, pre-operational stage, 2 to 7. More symbolic thinking is used to represent the world with words and images. Continued imaginary play, but much more sophisticated, especially if you read to a child and they play out stories or change stories. Centration. At this age, children may only consider one aspect of an object at a time. So there's a test he came up with called the Mountain Peak test. And you show a child maybe a model of a mountain, but they can only consider one aspect of that, one perspective of that view. They can't consider the view they did not see. Now I think maybe at 2 or 3, but after that I think they can do that. Egocentrism. Children may not be that empathic. For instance, they might hurt another child on a playground. But we have to teach empathy rather than just punishment. So it's important that they understand how another child might feel when they are hurt emotionally or physically. And I think they develop empathy at a very young age. All right, the next stage is concrete operational, 7 to 11 or 12, involves operations with concrete objects or examples. Piaget saw operations as mental actions that allow the individual to mentally do what had previously been done physically. So they do something physically, they can imagine it and play things out in their mind. They can experiment in their mind. These actions can also be reversed mentally. What if I didn't do that? What if I did it a different way? Children can think logically in concrete situations at this age. Children understand reversibility. If something changes shape, they're able to set the original shape in their minds. Children are able to understand conservation. All of these are vocabulary words that you have to remember. The ability to understand mass, even though the shape of the object changes. So if we have 2 different glasses, 2 different shapes, we fill one with water. It might be short and wide. And we pour that into a tall, thin glass. They'll understand that there's the same amount of water in both glasses, even though the shape of the object changes. Children can see objects in a series um, and classify them in multiple dimensions. This is known as class inclusion reasoning or classification. Um, it could be anything. Maybe they have uh, little toys and they arrange them by size, and then they might change it. They arrange them by color or anything like that. Formal, operational, 11 or 12 onward. Adolescents can think abstractly and logically, like algebra. Um, Adolescents possess hypothetical deductive reasoning. This means that they can design a hypothesis and test it out systematically. They can also do that in their mind if it's not too complex. Younger children would use trial and error instead. Um, One example is the 42 colored picture test. Can only ask yes or no questions. Quickest way is by dividing things in half through your questioning. So verbal problem solving ability is greatly enhanced. Adolescents become interested in ideas and concepts. Um, there's also more of a separation based on abilities. Abilities really become more noticeable. Um, and like I said, I believe every child has different abilities. Some are good at one thing, some are good at another thing. The trick is helping them to find those gifts. They may become interested in more philosophical concepts. Um, Another textbook by Sandrock gives an example of the adolescent thinking about thought itself. So that is meta thinking, why one might think about a thought. Ideals, future possibilities, fantasies, lots of impatience may accompany an adolescent's thought. And in your notes, there is a page to a book, but I believe that page changed. Not all individuals can obtain this full level of thinking. One study showed that only one of every 3 eighth graders obtain this level, though this may increase with age. Other studies differ greatly, such as between 17 to 67%, which is basically a full spectrum of college students reaching this level. Some developmentalists believe that there are 2 subgroups: early formal operational thought. The adolescent's ability to think in hypothetical ways produces unconstrained thoughts and unlimited possibilities. There may be an excess of assimilation, subjectivity, and idealism. Late formal operational thought. At the later substage, intellectual balance is restored through accommodation. Adolescents test the products of their reasoning against experience. So I think it is interesting. Piaget was flexible. You know, he wanted things to be correct. So in 1972, he revised his earlier timeline, said that formal operational thought could be completed between the ages of 15 and 20. Uh, there's also a great deal of variation between individuals. Educators have to learn to respond to the unique ideas and contributions of adolescents through appropriate communication. Spontaneous interaction with the environment or task should be encouraged. The curriculum should match the learning pace of the student, which is difficult in current large classrooms when ideally students need individual attention. So that is the theory. And I know this is a lot of memorization um, in a short amount of time. Make flashcards, whatever helps you to memorize, do your best. Thanks.